Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we're going to be covering Unit 3, Lesson 11. Today's topic is solve by completing the square. And I need you, of course, to put your first and last name, the period, and the date in the upper right-hand corner of your paper. Today's objective, I will solve degree 2 polynomial functions by completing the square. So let's jump right in. All right, so x squared plus 2x minus 9 equals 0. We have a degree 2 polynomial function. We can see that because we have an x squared term. 2 is our highest degree. And we need to solve this thing. So we could try solving by factoring. We could try using the quadratic formula. But today I want to teach you a third method for solving these types of equations. And that is completing the square. So first and foremost, we want to make sure that our equation is equal to 0, that y is 0 in this case. We're still solving for our zeros. We're still solving for our x-intercepts. And I just realized there's a huge typo on this paper. Sorry, I just got distracted by that. This should say solving by completing the square. Why does that say solvent? Who's in charge of this? Okay, this should say solving by completing the square, or solve by completing the square. Oh, excuse me for that typo. All right, so I have the steps written out here. There are 7 steps. I know 7 seems like a lot, but once you get the hang of it, it's really not that many steps, I promise. So first and foremost, step 1. We want to isolate the ax squared and the bx term on one side of the equal sign. So what that means is that we want x squared and the 2x on one side and everything else on the other side. So what we're actually going to do is for x squared plus 2x minus 9 equals 0, we're going to add the 9 to both sides. And I actually need you to leave a little bit of a space. So you're going to have x squared plus 2x is equal to 0 plus 9 is 9. And the negative 9 plus 9 canceled on the left side. So what we've done is we've left a little space here. And what we're actually going to do is we're going to find a new c term, a new constant to put here to help us make a perfect square. So to find our new c value, you take b divided by 2 and square it. And this will seem familiar because we used this method when we factored after we completed the square. So we're going to find c. So in this case, c is equal to b divided by 2. So our b value is 2. We're going to divide it by 2 and then square it. So 2 divided by 2 is 1. 1 squared is 1. So we're going to take x squared plus 2x. We're going to leave a little space equals 9. And then we're going to take what we found for c and add it to both sides of the equation. Because in an equation, if I do that to one side, I have to do it to the other. All right. So what happens is on the right-hand side, 9 plus 1 simplifies to 10. On the left-hand side, we're going to factor our ax squared plus bx plus c. And we're going to rewrite it as a perfect square. So to factor x squared plus 2x plus 1, to do this and to factor and then write it as a perfect square, we've already done this in one of our lessons. So you can either factor by grouping like we normally do, multiply a times c, rewrite your bx term, use your grouping symbols, all that good stuff. Or because we know both of these factors need to be exactly the same, we could just factor it in our heads. So I know I need to have an x times an x to get x squared. Then the only way to get 1 is to multiply 1 times 1. To get 2x in the middle, I would just add those together. So I know, let me explain what I just did. X times x gets us x squared. 1 times 1 gets us 1. And then the 1x and the 1x will add together to get us 2x if we multiply that to distribute it out. So again, if you need to factor by grouping, multiply a times c, rewrite your bx terms and all that good stuff. So x plus 1 times x plus 1 can be rewritten as x plus 1 squared. And we're ready for the next step. I also want to point out that when you factor, when you're completing the square, what was b divided by 2? So when we factor these, what we're always going to have is x plus or minus b divided by 2 times x plus or minus b divided by 2. I just want to point that out. That might make more sense as we go. Because what was our b divided by 2? 2 divided by 2 in this case was 1. That 1 is here and here, and then also here. So when we factor by completing the square, we're always going to end up with x plus or minus b over 2 times x plus or minus b over 2, or x plus or minus b over 2 squared. So that's like a little cheat for you. All right, step 5. Now, what we have is x plus 1 squared equals 10. What we're trying to do is solve for the x. Well, the x is being squared. How do I cancel a square? The only way to cancel something that's being squared is to square root both sides. But when we square root, when we're solving an equation, how many answers do we get? How many answers did the quadratic formula give us? It gave us 2, right, in front of the root. So when we square root both sides, we want to make sure that we always put the plus under the minus on that right-hand side. So this is the square root of x plus 1 squared is equal to plus or minus root 10. So then the square root of this square cancels. I'm left with x plus 1 is equal to plus or minus root 10. Root 10 can't be simplified further, so I'm going to leave it alone. Now I need x to be alone, though. So x has this 1 being added to it, so I need to subtract that 1 to both sides. So x is equal to negative 1 plus or minus root 10. There we go. This answer should look a little familiar. If we had used the quadratic formula, we would get the same answer. So this answer looks similar to answers that we've gotten in previous lessons. So of course, we have to write our answers as x-intercepts and as zeros. Our zeros are x equals negative 1 plus or minus root 10. And then our x-intercepts would be negative 1 plus or minus root 10, 0. All right, moving on to part B and C. So I'm going to help you get started with part B, and then I want you to do some of the steps on your own. So when I tell you to press pause and then press play, please do that. So step 1, isolate the ax squared plus bx terms on one side of this equation. So you're trying to get x squared plus 36x alone on one side. To do that, you need to get rid of the negative 81 or move the negative 81 to the other side. So go ahead and do that on your own. How would you get x squared plus 36x alone on one side? Press pause and then press play when you're ready to check your work. All right, so I bet you guys added 81 to both sides, which was the correct step. I added 81 to both sides, negative 81 plus 81 cancel, 0 plus 81 is 81. So now I have x squared plus 36x, a little bit of space, equals 81. Now we need to find c. So to remember, to find c, you're going to take b, you're going to divide it by 2, and then you're going to square it. So go ahead and do that and see what you get. Press pause and then press play when you're ready to check your work. All right, so b in this case is 36. 36 divided by 2 is 18. 18 squared is 324. So our new c value is 324. Our next step, we're going to add that value to both sides. So we have x squared, sorry, I guess I could zoom in. X squared plus 36x plus 324 is equal to 0 or 81 plus 324. We're adding it to both sides of the equation. All right. So now we need to factor the right-hand side and then write them as perfect square. So remember, when we factor this side, both factors are going to be the same. So we're going to try to do this in our head. And then we need to add 81 to 324. We get 405. All right, so let's try to factor this. I know I'm going to have x times x to get x squared. And then I know that 18 times 18 was 324. So remember, you always use b divided by 2 here. Then I can rewrite x plus 18 times itself as x plus 18 squared equals 405. So now we're ready to solve for x because we have a perfect square here. We've got something being squared, x is inside. And so now what do? We take the square root of both sides. So we're going to take the square root of the left-hand side and the square root of the right-hand side. Remember, when we take the square root, we get two answers. So we want to make sure we put a plus or minus in front of the radical on the right-hand side. So we're going to have the square root cancels the square. We're left with x plus 18 is equal to plus or minus root 405. Now, we are going to solve for x and then simplify both sides of the equation. So we have x plus 18 on one side. How do I cancel that 18? I subtract it to both sides. So I'm going to have x is equal to negative 18 plus or minus the square root of 405. But we need to see if the square root of 405 can be simplified or not. I'm going to grab my phone so I can use my calculator. Ain't no shame in using a calculator sometimes, right? All right, let's see if let's see, 405 ends in 5. So I'm going to, I know it's divisible by 5. Ooh, it's 5 times 81. So we're going to have x equals negative 18 plus or minus the square root of 5 times 81. Well, 81 is a perfect square. So I can bring the square root of 81 out in front. I'm going to have x is equal to negative 18 plus or minus 9 times root 5. And then, of course, we write our final answers as zeros and x-intercepts. We're going to have our zeros are x equals negative 18 plus or minus 9 root 405, 9 root 5. And then our x-intercepts are negative 18 plus or minus 9 root 5, 0. There we go. All right, let's go ahead and try another one. So I want you to do part C on your own. You've got all the steps. We've practiced it a couple times together. I want you to do this one on your own in just a second. But I want to give you a hint. So remember that you need to isolate the x squared and the 6x terms, or the bx terms, the ax squared and the bx terms. Well, in this case, our x squared is over here on the left and our bx is over here on the right. Since the x squared is negative, I highly recommend that you make it positive by adding it to both sides. And then you'll end up with negative 9 is equal to x squared plus 6x, and then proceed from there. For completing the square to work, you always want your a to be 1. And in this case, now it is 1. You want it to be positive 1. All right, go ahead and do the rest of the steps. Solve by completing the square and see if we both end up with the same answer. Go ahead and give it a shot. Press pause and then press play when you're ready to check your work. All right, let me walk you through what I did. So as you can see, I found C by taking B, which is 6, dividing it by 2 and squaring it. 6 divided by 2 is 3, 3 squared is 9. So then I used that new C value and I added it to both sides. What we do to one side of an equation, we have to do to the other. Then I have negative 9 plus 9 simplifies to 0. And then on the other side, we have x squared plus 6x plus 9. When I factored that, I ended up with x plus 3 times x plus 3. Then I rewrote it as 0 equals x plus 3 squared. For the next step, I know I need to cancel that square so the x won't be squared anymore. So I square rooted both sides. When I square root both sides, I know I need a plus or a minus. Well, the square root of 0 is just 0. So we have x plus 3 is equal to plus or minus 0. Then I subtract 3 to both sides. And then x is by itself, which is equal to negative 3 plus or minus 0. Well, negative 3 plus or minus 0 is just negative 3. And then I showed that to you by saying, well, x equals negative 3 minus 0 is x equals negative 3. X equals negative 3 plus 0 is x equals negative 3. Since I got the same answer both times, I only need to list it once when I write my zeros and my x-intercepts. I only have one x-intercept, or 1, 0 in this case, and that is x equals -3, and the point -3, 0. Hopefully our answers matched. All right. Now we're going to do something that's, I think, is kind of cool. We're going to start with the zeros and then write the equation from that. So what we've done in the past is we always started with the function, factored it, or used the quadratic formula, or now we're completing the square, and then we solve for the zeros. Well, now we're going to be given the zeros and we have to work backwards to find the equation or the function that they came from. All right, so our zeros are x equals 6, -3. Well, where did those zeros come from? Those zeros came from solving the function, or setting the factors equal to 0 and solving for x. So I know that these zeros came from x equals 6 and x equals -3. So you want to set, our very first step is set each zero equal to x. Then you want to make each of these little equations equal to 0. So we want x equals 6 to be equal to 0 instead of 6. To do that, I subtract 6 to both sides. So I end up with x minus 6 equals 0. For the other one, I would add 3 to both sides, and I end up with x plus 3 equals 0. Now, x minus 6 equals 0 and x plus 3 equals 0. This x minus 6 and this x plus 3, those would have come from the factors of our function if we had factored it. So I can rewrite it as factors. So I'm going to write them as factors. X minus 6 times x plus 3 and set that equal to 0. So what we've done is we've written our equation with the factors that we found from working backwards from our zeros. So we're just like, we're working backwards. We're doing the opposite. Now we're going to multiply that out and then replace 0 with y to write our final equation. So we're going to have y is equal to, we're replacing 0 with y. And we're going to say x times x is x squared, x times 3 is 3x, negative 6 times x is negative 6x, and negative 6 times 3 is negative 18. So I just distributed the x and then the negative 6, which we've done plenty of times. So then y is equal to x squared minus 3x minus 18. And that's all there is to it. So just like if we had started with y equals x squared minus 3x minus 18, the way I would have told you to solve it is by factoring. So you'd have 0 equals x squared minus 3x minus 18. We would have factored it to x minus 6 times x plus 3. You would set each factor equal to 0 and solve for x. So we just did that backwards. We started with the zeros, which is this step right here. Then we made them equal to 0, which is this step here. Then we put them into factors, which is this step here. Multiplied it out and got our function, which is our final step. When we solved them, that's what we started with. So I'm just showing you that it's just flipped. All right, let's try it one more time together. Our zeros are x equals 4 and x and 5. So I write them out as zeros, x equals 4 and x equals 5. Then I want them equal to 0. How do I make 4 become 0? I subtract it to both sides. So I get x minus 4 equals 0. Same with the 5, I subtract it. And I get x minus 5 equals 0. So these things are the factors. So I put them as factors. So I'm going to have x minus 4 times x minus 5 equals 0. I put them into one equation as factors and set it equal to 0. Then I want to switch my 0 to a y because I want the original function that we started with, and then that we would have started with. Then I multiply things out. I multiply x times x. I multiply x times negative 5. I multiply negative 4 times x and negative 4 times negative 5. Then I get x squared minus 9x plus 20 equals y. Or I can move the y equals on front. There we go. All right, now I want you guys to try part C on your own. So part C, I gave you as x-intercepts instead of zeros. But if you wrote these as zeros, what would they be? Wouldn't they be -2 and -1 if they're coming from the point -2, 0 and -1, 0? So go ahead, follow all those steps and go ahead and do this problem on your own. Press pause and then press play when you're ready to check your work. All right, let's compare your work to mine. So our zeros are x equals -2 and -1. So I set x equal to -2 and x equals to -1. I added 2 to both sides. I got x plus 2 equals 0. I added 1 to both sides. I got x plus 1 equals 0. Then I put them in factors and set that equation equal to 0. So x plus 2 times x plus 1 is equal to 0. I replaced my 0 with y, so I have y equals, and then I just distributed. So I got x squared plus 2x plus 1x plus 2, and then simplified that to my final answer of y equals x squared plus 3x plus 2. Hopefully our answers match. All right, I believe that's it for today for our notes. So go ahead and get started on your extra practice, and I'll see you back in class. Have a great day.